moving forward, we have Dr. Nandita Kumari, who is giving a presentation titled Different Trends of Variation in Christiansen Feature on the Lunar Surface, Effects of Iron Content and Particle Size. You can feel free to take it away whenever you're ready.
Jim, you'll have to stop sharing your screen. So
yeah, I'm trying to find it. I'm trying to find a control for that.
I think it's, there you go.
There we go. Okay, what do I do here? Sorry, stop, just get rid of this. Yeah.
Just mute yourself and we can move forward.
Let me, I'm just trying to I don't know, share my screen right now.
Yeah, sure, okay.
Okay, give me a second. I don't know, it's just asking me to leave the meeting. I'm sorry about that. Okay, Deborah, I have kind of sent you an email because I was kind of, prepared for this, that if anything goes wrong. So you'll have my slides if you do not mind. Would you mind sharing them, I guess?
No, I don't. Let me go to my email and find them. They are not in my email.
Oh,
there they are. Okay. Okay, so give me a second and I'll put your slides up for you. Share screen. I'm just going to share your talk. Oh, now you're going to have me multitasking. We'll see how well I can do that. Can you? All right. Can everybody see her slides?
Yes, we can. This is great. Okay. Cool. I think I'll just start. So hi, I'm a grad student at Stony Brook University, so not a doctor yet, but yeah. Well, so I'm going to talk about variation in Christiansen feature with respect to albedo on the moon next. So this is kind of the overview of the talk. I'm going to talk a bit about CF, the factors that we know that affect CF, why am I doing this project, a bit about space weathering, variations in it, and then what have I done next, more or less. Next slide. So thermal infrared emission spectroscopy is a very broadly used tool to identify silicates on airless bodies. So CF is the emissivity maxima in this regime. And it's an indicator of silicate degree polymerization in a mineral. And so it's a very useful tool for determining the bulk composition. These three lines that you see are the three brands of diviner instrument that I'm using for doing my study. Around band 3, 4, and 5, around 7.9, 8.2, and 8.5. Next. So we know that there are some factors that affect CF. And so prior to analyzing diviner data, we thought that CF, since it's at a longer wavelength, it will not be affected by any other factors, as particularly the effects that we see in VNIR. But after analyzing diviner data, we came to know that space weathering, regolith compaction, and particle size, all of these affect CF. And just to be more specific, an increase in compaction and space weathering leads to a redshift in CF, and a decrease in particle size also leads to a redshift in CF. Next slide. I'm doing this project particularly because silicate minerals, they're very abundant across the solar system, particularly across the solar system. And we use thermal infrared a lot for studying silicate minerals, particularly the bulk composition. It is very important to quantify the factors that influence CF for an accurate interpretation of the remote sensing data sets. It will not only have use for our current data sets that we have, but also a lot of upcoming data sets and ongoing missions, such as OSIRIS-REx, Baby Colombo, and Lunar Trailblazer. In data sets, I've used diviner's CF data, band 3, 4, and 5, and Kagua multiband imager. I'll be going through the methods a bit in detail in a few minutes. Next slide. So talking a bit about space weathering. So space weathering is a term that basically gives it's the cumulative effects of processes that is active on the materials in space environment. It leads to formation of agglutinates, glasses, and then also leads to formation of nanophase metallic ions as a coating on the mineral surfaces. It also leads to reddening of continuum in near IR region, and also like in decreasing of depth in visible region of the minerals, ion absorption depths. Next slide, please. So one thing to start with is like, is the space weathering same for all the minerals? They are not. So it is not. Why? Because so there's this study by Allen 1993, which states that he or she did the study on different minerals and found out that the amount of nanophase metallic ion particles that form are relatively different for different minerals. For instance, in synthetic glass, around 80% of original iron in the mineral structure got reduced to nanophase ion particles. It was 40% in case of olivine, and it was even less in case of enstatite, and like further reducing into like a lot less in augite. So these are like the red globules that you see on the surface are those nanophase metallic ion particles, and you can see them decreasing with the decrease in ion content of the mineral. Next slide, please. So space weathering leads to darkening of the surface. So this is a young crater, I think it's Dionysius, on the lunar surface. So you can see like it has a bright ray pattern around it, but like with time it darkens. As you see, like the surface around it is relatively dark. It also leads to like a lot of polarization and like breaking of rocks into fine regolith. So now we also know that space weathering affects CF, but like we are kind of going into look into detail how does it, and like what all things do we need to look into to make sure that we are getting the bulk silicate composition correctly. Next slide, please. So to do this study, the ideal sites would be Copernican craters because they have a bright ray pattern around them, and also like they overlay on a relatively older surface. So they have like essentially the same silicate composition, but different albedos. Same is the case with soils. So soils have these bright ray patterns, and the most, I would say, like there are multiple hypotheses floating around in the community, but the one that is more prominent is that it's due to the magnetic magnetic shielding of the solar winds, which kind of slows down the process of, I would say, the process of darkening in the soil regions. So yeah, you see these bright patches, as you can see on the right. So I've taken these two sites like across the different locations and looked through them. Next slide, please. Okay. So this is not showing correctly, but anyway, these are the locations. These are the locations that I took across the lunar surface: the Highland craters, Highland soils, Mare craters, and Mare soils. The total number of locations I took were 23, and the red squares are the ones that I'm going to discuss today. But like I've done the same study on all of them. Please, the next slide. Okay. So now, first thing I looked was the variation in CF with respect to albedo in the lunar highlands. So in highlands, this is a highland crater, Giordano Bruno, and here you can see like I've taken two locations with essentially the same silicate composition, but bulk silicate composition, but different albedos. And as you can see, with the decrease in albedo, CF shifts towards longer wavelengths, or like it leads to a redshift in CF, not redding, but rather a redshift in CF. Next slide, please. This is Highland soil, Van de Graaff in Van de Graaff crater. So here also we see a similar phenomena of like a redshift in CF with the increase in with the decrease in albedo, not increase, with the decrease in albedo, as is like evident from the scatter plot and the histogram. Can we go to the next slide, please? This is a Mare crater, Kepler. The similar study reveals kind of the similar results, that the CF shifts to like longer wavelengths, essentially having the same bulk silicate composition, but still it shifts to longer wavelengths for highly space weathered regions. The next slide, please. Okay, so so this is rhinogramma. So here I did it for like the dark lanes as well as the dark lanes, the bright spots, and the region nearby with relatively lower albedo. And you can see a continuum in the shift of CF. So like the dark lanes have shifted a little, while the dark spots, the dark region around the soil is like significantly shifted. So like basically this soul is a good example of showing that this shift is not like, a constant number or anything. It's a continuum. With time, the shift increases towards longer wavelengths. Can we go to the next slide, please? Okay, so now let's look at the particle size effects. So here you can see craters in blue and the source. So this is all the 23 locations, and you can see like essentially for the same albedo change, there has been like significantly different changes in CF. Craters have undergone more changes in CF compared to like soils, and this is because crater ejectas are essentially blockier, as in like they're larger in size, so it also like leads to breaking down. So there is a change in particle size that happens along with a change in the nanophase formation of along with the formation of nanophase metallic ion particles. So in craters, you are like the particle size variation is more prominent. So that is like kind of visible here, that essentially for having the same albedo change, craters have like more significant CF change compared to soils. Can we go to the next slide, please? So here it's like, since I selected the locations both on Mare and Highland, we see a different trend of CF variation in Highland and Mare. Now Mare are like more, like they basically consist of more mafic-rich minerals compared to Highlands, which are like more felsic. So here we see that, essentially for like same CF variations, like comparable CF variations, the albedo changes in Highlands are a lot more compared to albedo changes in CF. So even for like, even if the, what I essentially want to say is like for the same amount of space weathering in Mare, the CF change will be significantly, like literally higher than that in Highlands. So yeah, next slide, please. Combining both of them, looking at the Highland craters, Mare craters, Highland soils and Mare soils, we see that for like the craters again, in both Highland and Mare, we see that, as I said, like for the amount of same CF change, you see like a different amount of albedo change. And when you look at like the soil and crater comparison, the crater like for the same amount of albedo change, you see like CF of crater is like has changed more than the CF of soil. Conclusion and going forward. So first thing is like most of the corrections that have come for CF do not take into account the initial composition, the primary composition of iron in the mineral. So we need to take that into account to quantify these changes and also to explain these changes. So as I said, the increased variation is due to like presence of different minerals with different iron composition in these two locations. And going forward, it is like, so when we talk about the steady state, reaching steady state due to space weathering in VNIR, like the thing is there a definite amount of CF that needs to change after which it just stops changing, that we reach the steady state and it will not affect the CF changes anymore? So we have to like kind of look into that. Is there a definite amount, or like, it varies with minerals? Also like quantify variation in CF due to like thermal gradient on the top few microns that builds up. And also understanding that the different factors that affect CF change, are they like additional, like for instance, does the CF change only due to space weathering add on to the CF change due to particle size and thermal gradient, or like how are they related to each other? Like yeah, so that is my talk. Thank you.
Thank you so much. Do we have questions? So I was not able to monitor the chat while doing that. But do we have any questions for Nandita? And forgive me if I mispronounced the name. So I have just a basic question. How are you proposing to take a look at these changes in CF and albedo to separate out, say, space weathering and particle size? Do you have a test in mind to separate the effects of those?
Yes. So me and Tim, my advisor, are kind of planning to do this laboratory work where like we are going to take the same sample of like different particle sizes and like kind of reduce them, and then like see how much CF changes for the same particle size and also for the different particle size. Then like we can kind of do a comparison that was, if it is same, then it is possibly like the same, essentially the same phenomena. But if it is different, it means that they're they might be adding up, like, the particle size is also increasing it along with the space weathering. So it's like taking the same sample in different particle size and in the same particle size, reducing them, and then like comparing the changes in CF. But that's essentially a lab work that like we are planning to do sometime.
Oh, I can't wait for your results. Ben, we need to move on.